Have you ever thought about what it takes to get a car up to 200 miles per hour? Why not 300 miles per hour? Well, it's not easy at all, and you can't just put a big, powerful engine in a car and make it go close to 300 miles per hour. People don't realize how much engineering and special parts go into a car that can go close to 300 miles per hour, or what goes into the new Bugatti Chiron 300 Plus, which set the world record for speed at 304 miles per hour. Today's video reveals why it's impossible for cars to go 300 miles per hour. It explains what matters to get a car to go that fast safely, and what we can expect from top-speed hypercars soon. Let's get started. Supercars are necessary because of humanity's insatiable need for speed. This is why the auto industry has never ceased thinking about and creating better, faster cars. A few businesses, Bugatti being the recognized first, have recently been able to build and produce road-legal cars that can exceed the 300 miles per hour threshold. The Ferrari F40 was the first street-legal vehicle to reach 200 miles per hour in 1987. The Veyron hypercar from Bugatti surpassed the 250 miles per hour barrier in 2005. The Bugatti Chiron Super Sport was the first production vehicle to achieve 300 miles per hour by the end of 2019. However, the speed at which technology has developed over the 21st century begs why it has just taken more than 14 years to go 50 miles per hour faster. Well, the 300 miles per hour formula has a lot of different variables. Overcoming the 250 miles per hour limit happened over 14 years ago. However, it was not as simple as just picking up 50 more miles per hour. If you've ever driven a car at high speed, you may have observed that reaching 100 miles per hour from 50 miles per hour requires much more energy than reaching 150 miles per hour from 100 miles per hour. Aerodynamically speaking, downforce, lift and drag exponentially increases as a square of speed. A car that can travel 270 miles per hour would require a significant increase in efficiency to reach 280 miles per hour. The assumption that an automobile needs twice as much power to travel at 300 miles per hour as it does at 150 miles per hour is untrue. If a particular vehicle can travel at 150 miles per hour with 200 horsepower, it would require 1,600 horsepower, or 8 times as much power, to travel at 300 miles per hour. It takes a lot of strength to overcome a force like air resistance or drag. An item must be pushed through the atmosphere with an increasing force proportional to its velocity. In other words, a car would require 1,600 horsepower to go 300 miles per hour from 150 miles per hour, where 200 horsepower is required to overcome aerodynamic drag. One of the major obstacles that designers and engineers must overcome while trying to break speed records is aerodynamics. As the speedometer needle rises, air changes its flow and takes different paths across the bodywork, behaving differently depending on the speed. Since the downforce necessary to better cornering causes even more air resistance, the car must be specifically constructed to be driven at those high speeds, which typically translates into poor performance on the track and in corners. The fact that air resistance increases in squares, meaning the vehicle must exert a squared amount of energy for every additional mile per hour of speed, is another crucial aspect of the design. The dose of force required to propel a mechanical beast over 300 miles per hour is dictated not only by the engine's displacement, but also by the volume of air and fuel injected into the combustion chambers, the pace at which the engine spins, and dozens of other factors. In addition, the engineers must ensure that the engine is dependable and does not fail under the extreme pressure placed on it by the requirement to generate such ludicrous levels of power to achieve speed records. The caliber of these pieces of equipment is quite essential. We can gain insight into how Hennessy chose to make their 300 miles per hour surpassing hypercar by examining the 1,817 horsepower Hennessy Venom F5 and its powertrain. While the 8.0-liter V16 engine of the rival Bugatti has a redline of 6,000 RPM, the F5's twin-turbocharged 6.6-liter V8 engine can reach 8,600 RPM. Here, the smaller, faster-spinning engine makes up for the displacement and cylinder count. Think about attempting to break the world record for the fastest jogging while wearing a pair of slippers. If there are no suitable ways to secure the vehicle to the ground, the earlier research about power and aerodynamics is meaningless. Nonetheless, creating an automobile that can travel at 300 miles per hour requires more than just a huge engine. You must begin with the tires first. Tires are one of the most crucial auto parts of any performance-oriented design because they are the only contact points between the ground and the vehicle. A standard tire cannot withstand the tearing force, which can reach speeds of 300 miles per hour and weighs almost 7 tons. The Bugatti's tires had to endure 7 tons of tearing force to keep spinning at that speed minus 68 times per second. To put that into viewpoint, consider that a Porsche 911 moving at full speed only experiences roughly 3. Bugatti's solution to the tire problem was to construct a rather thick layer of carbon fiber beneath the tire's carcass, reinforcing the tire and preventing more weight from being added. However spectacular the advances of these automakers have been, none of it would be possible without the development of testing. A week-long aerodynamic simulation may now be completed in 3 to 4 hours, enabling the quick testing of new ideas. Additionally, even though Bugatti may have been the first car to surpass 300 miles per hour, the auto industry is continually striving to break previous records. Even though reaching 300 miles per hour was a significant milestone for the automotive industry, we already know that the next one is only around the corner. However, as speed increases, it becomes more difficult for man-made machines to move faster. When it comes to legally driving gas guzzlers supercars, no one really knows where the line is, but we can be sure that the desire and ambition will never end. That's it, guys, on why it's impossible for cars to go 300 miles per hour. Do you think technology will be crazy enough to overcome these challenges in the future? Send us your ideas and considerations in the comment section below. If this video is insightful for you, then go on and like this video. Please kindly subscribe to our channel and click on the bell button for more of our updates.